functions of skin. So this kind of probably should have started first. So the skin forms an important barrier for the body. That is kind of one of the big, most obvious things that it does, is it gives us the boundary between us and the external environment. So that's going to be, as far as its protective functions go, that's going to be one of the big things that it does. So for protection, the skin is going to be able to give us protection from a variety of mechanisms. So our skin is continuously exposed to microorganisms, abrasion, temperature extremes, harmful chemicals. So we really need to have a lot of stuff in there to kind of protect us. So the three barriers that are going to give us protection are what we call a chemical barrier, a physical barrier, and a biological barrier. So this chemical barrier is created because your skin is acidic. And so that creates what we call the acid mantle of the skin. And it's just that because of the slightly acidic pH of sweat, because sweat contains nitrogenous waste and things like that, it makes it slightly acidic, and it makes it hard for microorganisms to grow. So we could say a chemical barrier is that we would say the low pH of the skin, low pH due to sweat, creates the acid mantle. So our low pH due to sweat creates the acid mantle, and this acid mantle prevents microbial growth or regeneration. So it kind of has antimicrobial properties. Okay, so that's kind of the most important chemical part. It acts as a physical barrier, and by containing those keratinized cells, that's going to help to kind of give it some resistance on taking in chemicals that are released by microorganisms and things like that. So for our physical barrier, I mean, it's pretty obvious that it's the physical barrier anyway, but another part that we could say about it is that the keratinization is going to help without, so that we're not taking in fluids and things. So since, let's just say this, the keratinized, stratified squamous epithelium is going to prevent the entrance of chemicals and fluids, or I guess I shouldn't say prevent, slow. The goal is to prevent the entrance of chemicals and fluids. And then it can act as a biological barrier because we have cells that are living that will kind of help fight things off. So dendritic cells, the resident cells that are hanging out in your epidermis would be one part, but also in our dermis we have blood supply, so we can have macrophages wandering in and out. So there are cells present in the skin that can help with this. Again, in the epidermis, there are dendritic cells. What layer are dendritic cells found in? Oh. Dendritic cells are found in the stratum spinosum. So our stratum basale is the deepest layer. They're one layer up from that, wandering around. And then, so in the dermis, since the dermis has its own blood supply, white blood cells can get there, but also the dermis has resident mast cells. These release inflammatory chemicals. I brought that up just kind of as a side note yesterday, just be aware of it. these reside there, mast cells do. But then white blood cells like macrophages can get in and out as needed because of the blood supply. So white blood cells can also get in there due to our blood supply. But blood supply. The white blood cells can get in because the dermis has a blood supply. So epidermis doesn't have blood supply. Dermis does, so the white blood cells can get out of the blood and into your dermis to be fighting stuff. Okay, so those are kind of the physical barriers that are provided. The next important function that is served by the skin is body temperature regulation. And why is that? Because what do we have in the skin that we can do something about? Sweat glands. And what about when we're cold? Well, I mean, it works both ways, when we're cold or hot. We have blood vessels that can constrict or dilate to move the warm blood away from the body when we're too hot, out to the surface by those sweat glands, so we can lose heat through evaporative cooling, or to constrict and bring warm blood into the body when it's cold. So for body temperature regulation, that's the second important function. And remember, this was the example that we used for negative feedback in chapter 1. So what do we have to do in order to do anything? It contains not only the things that can bring about a change, but it's got our thermoreceptors. So we've got hot and cold thermoreceptors that are going to detect the change and communicate that information, of course, back to our brain and specifically the hypothalamus. Now you can know that because you have to know the hypothalamus. So the hypothalamus is the master regulator of the autonomic nervous system. Are you thinking about dilating your blood vessels when you're hot and turning on your sweat glands? Not at all. It's automatically happening. So our thermoreceptors are going to tell our hypothalamus, and our hypothalamus can then activate effectors in the skin. So in the skin, we have blood vessels, we have sweat glands, and there's actually one other thing that's going to be important to a hair follicle. We're starting backwards because I want you guys to be able to work together and draw a hair follicle and include all the important stuff. So the other thing when it's cold is that you can shiver. So you will shiver. You're going to have these skeletal muscle contractions. And another thing that you're going to do is you're going to stand your hair on end. You get goosebumps, right? That's because of these little muscles called erector pili muscles. So our erector pili are going to stand our hair on end, and we'll get goosebumps, and we'll shiver. And so if we shiver, then we have skeletal muscle contraction, and skeletal muscles are our major contributor to body heat, because heat is the byproduct of cellular respiration. And your skeletal muscles are always contracting to some level, so they're going to be our major producer of body temperature. So that's how the skin's involved in body temperature regulation through its effect on those effectors. Any questions on that? Okay, then the other thing that the skin does is provide our cutaneous sensations, and that's because it contains all of these sensory receptors that we've talked about in chapter 13. Is everybody good on this? Shout no if no. Okay, so the epidermis only had one type of cell that was responding to any kind of touch. What was it? So this function that we're doing right now, talking about right now, are cutaneous sensations. So these are the things that we feel because of the receptors in our skin. So in the epidermis, it's modified, but we talked about it yesterday. It's a modified thing. The cell on its own has a little free nerve ending hooked up to it. And the two together make a tactile disc. So in the epidermis, we have tactile cells. In what layer? In order to be in contact with the free nerve ending, yeah, in the stratum basale, exactly. In the basal layer, we have our tactile cells that are going to hook up with the free nerve ending that's coming in, and the two together make that tactile disc. So epidermis has that, but then our dermis has all of the other ones. So we could say now this with our nerve ending is going to give us a tactile disc. But our bulbous corpuscles, our Ruffini corpuscles, our Meissner's corpuscles, all of the rest of those receptors are found in your dermis. And so they're going to help provide these cutaneous sensations. All right. Any questions so far on the functions of skin? So, metabolic functions. Metabolism is the sum total of chemical events in your body, building stuff up and breaking stuff down. So there are chemical reactions, you can think of them as chemical reactions. So in the skin, as far as metabolic reactions go, the precursor to vitamin D3 exists in your skin. And when UV radiation hits it, it activates it to active vitamin D3. And you need that for calcium absorption. So for a metabolic function, we could say that the precursor for vitamin D3 is in your skin, and it gets activated with UV radiation. Vitamin D deficiency is one of the biggest problems in adults right now, in people right now, because we put on sunscreen and all of this stuff, which is good because we don't want skin cancer, but we need to be able to make vitamin D because it's really hard to absorb calcium without it. Calcium is a big cation. It's got 2 positive charges. So what's going to happen is this vitamin D3 is going to go to your liver and it's going to become this stuff called calcidiol. That's going to go to your kidneys and become this stuff called calcitriol. Calcitriol is going to work synergistically with a hormone that we're going to talk about when we get to bones called parathyroid hormone. And together those 2 hormones are going to stimulate your small intestine to uptake calcium. So I promise you, when we get to the skeleton, that negative feedback loop is going to be tested and going to be drilled through. I'm not going to test you on it now, but I might ask you what's a metabolic function of the skin. And you would say it's to produce, ultimately, active vitamin D3 because it contains the precursor. So if you have completely free exposure of your face and hands to the sun for 15 minutes a day, 3 times a week, you should be able to synthesize enough. But again, a lot of us are putting on our oil of Olay with SPF 15 and whatever, and our gloves when it's cold or whatever. So a lot of us don't have enough vitamin D. And so that can be one of the problems with bone health later on, is if you can't absorb calcium, then it makes it harder to maintain your bones.
So is there a difference between vitamin D2 or D3 when it comes to...
It's all in chemistry.
Okay.
But yes, there's a difference. And vitamin D3 is the one that we need.
What is in our skin?
That's
what we're activating.
We're activating it to vitamin D3 is what we've got to get. So it's enough to say the precursor's in the skin, and if you take biochem someday, you can go through all the nitty-gritty details. Yeah.
No.
Okay, the other thing that the skin does for a function is it acts as a blood reservoir. What do reservoirs do? Hold stuff, primarily water. I don't know of many other types of reservoirs. But, so this function, acting as a blood reservoir, means that your skin can hold extra blood. Well, what does that mean? Well, at any given moment, most of your blood is in your venous circulation, which isn't under the pressure of your heart. So it's your blood hanging out in your veins, and we can access more of it by doing something that squeezes our veins more. So when you're sitting here at rest, you have a pretty set amount of blood supply that you need. You're pumping about 5.25 liters per minute. So almost your entire blood supply is going through your body in 1 minute. But if I need to increase that, let's say I'm in a fight or flight situation, I can actually increase the output of my heart to like 35 liters of blood per minute from 5. How do I do that? Well, I increase my heart rate and I increase my cardiac output, all this stuff we're going to talk about next semester. But one of the things that I'm doing is I'm squeezing on my veins and bringing all of this blood back to my heart faster. So I have like 55 to 60% of my blood in my veins. So if I start fighting and fleeing and squeezing on it, it's bringing it back. And if it's bringing it back to my heart faster, I can pump it out faster and I get more cardiac output. So because there are so many veins, superficial and in our skin, we can say that there's blood stored there. It's not like we're going to access it on any, you don't access your blood reservoir on a regular basis, but if we need it, if we need to increase our cardiac output, we have it. So for blood reservoir, what we can say is that the veins in skin hold extra blood. That can be accessed, for right now we'll just say when cardiac output needs to increase. And what is cardiac output? Well, cardiac is my heart and output is output. What does the heart output? Blood. So it's more blood flow. And that's all you need to know for now. So veins in the skin hold extra blood that can be accessed when cardiac output needs to be increased.
And you said it could go up to about 30 liters per minute?
35 liters per minute in the most highly trained athletes. Okay, then another thing that our skin helps us with is the excretion of waste, and that happens through sweat. So we can excrete waste through sweat. So sweat contains nitrogenous wastes, like urea and uric acid. So it can be used for, skin can be used for excretion. Okay, so those are the functions. Any questions? All right, glands. So we have different types of glands in the skin. Sweat glands, oil glands. So sweat glands are also called Odoriferous glands. Of all of the silly ways that I have to remember things, this is my daughter's least favorite. I remember that sweat glands are Odoriferous. Odoriferous glands are sweat glands. Odoriferous rhymes with odoriferous, and odoriferous stinks. And she's like, odoriferous isn't even a word! Whatever. Odoriferous, sweat glands. So what types of sweat glands do we have? Over all of our body, we have these sweat glands that their name is Exocrine. Exocrine sweat glands. So these cover the body. They release a watery, salty sweat. This is where we're excreting those excess wastes. So they're going to release a watery, salty sweat. They are merocrine by method of release. Does anybody remember what that means?
They secrete their waste as they make it.
By which process though?
Oh.
Exocytosis. So they're merocrine by method of release, which means they are going to use exocytosis. Okay, in our axillary and pubic regions, we have apocrine sweat glands. And these release a protein-rich sweat. And they become active at puberty. So, again, we find these in the axillary and pubic regions. They become active at puberty. This sweat is actually odorless when it comes out, but the microorganisms living on your skin eat that protein and release byproducts that makes it stink. So body odor is coming from the bacteria living on your skin, eating that sweat, not because that sweat actually smells.
So this is where teenagers start to stink?
Yeah, that's why teenagers start to stink. Yep, and they're super active during this time. And so this sweat is thought to be involved in chemical signaling. Well, it's known to be involved in pheromonal signaling. Did we talk about Dormitory Syndrome? Did I tell you about that? Okay, because I was holding it for now. So they noticed, you may have heard that females will sync up their menstrual cycles. And so when you're a scientist, you want to study stuff like that, but you have to control as many variables as possible. And they noticed it really in big numbers in females in college dorms. And so the first question is, well, okay, but maybe it's just happening because they're eating the same stuff, they're on the similar dark cycles, have similar environments, so maybe that's why they're syncing up. So what you do then is you get the girls at CU Boulder and the girls at CU Denver, and you get them all to participate in a study by, bribing them with $50, and you're like, yeah, that'll buy 500 ramen noodles, so I'm going. And you sign up, and you're at CU Boulder, and they give you a pad to put in your armpit. And every day you just put a pad in your armpit, and at the end of the day you take it and you turn it in. And that's if you're at CU Boulder. And if you're at CU Denver, all you do is come in and sniff a pad every day. And you don't know what you're sniffing a pad. And so you walk in and you sniff that pad, you do that every day for a month, and you can start syncing up the CU Denver females to the CU Boulder females because they're sniffing their apocrine sweat. So they call that pheromonal signaling, when we're signaling from one human to another. This also contains other things. There's another type of signaling. They say that dogs and bees smell fear. Dogs and bees smell that in your apocrine sweat. So that they call allelomonal signaling. So when another species can respond. So those proteins are containing important chemical messages. So that's just one thing to be aware of. So if we're looking at these two types of sweat glands, which are more important in body temperature regulation? Accurate. So these are important for body temperature regulation, and these ones are important for signaling. So, and as far as method of release goes, there's starting to be a growing body of evidence that suggests apocrine sweat glands are using exocytosis. In the past, it was thought that they're using apocrine release. So either answer you give me will be acceptable. So apocrine release, what's that like? Like, how does it work? Exocytosis, you're packaging something into a vesicle and releasing it.
Vesicles burst.
Yeah, so in apocrine secretion, what happens is at the apical surface, you accumulate your product, and then it pinches off into the duct. Okay, and then the last type of gland that we find in the skin is a sebaceous gland. That's not true, because we have ceruminous glands as well. But this is what I want you to think about for our hair follicles. Sebaceous glands are these glands that are associated with every hair follicle, and its duct is going to empty onto that hair follicle. And the product that they're releasing is called sebum. So our sebaceous glands, they are holocrine by method of release. What does that mean? The cell accumulates its product and then disintegrates into the pore. So sebum is a really oily substance. So it's holocrine secretion, so we'll say it's holocrine secretion of sebum. Sebum is the fluid, and it's oily. And what this does is as the hair is growing past and sebum is being released onto it, it's making the hair soft and pliable. So sebum makes the hair soft and pliable. Hair is dead keratinocytes. Dead keratinocytes are pretty dry. So to make it nice and soft, sebum is added as it's growing past. Okay. So a modified type of sweat gland that we find in the ear is called the ceruminous gland. And these release cerumen, which is earwax. So we find this in the integument of the ear canal, and earwax is sticky and bitter. So it serves a protective function by hopefully preventing bugs and things from crawling in your ear. So if a bug does crawl in there, a couple things are going to happen. It's going to taste that bitterness, and its feet are going to stick. So it's going to want to get out. So earwax is both bitter and sticky. So hopefully it prevents insects from staying in your ear canal. Okay, those are our glands. Any questions on glands? So what's cool, if you look here, this is our hair in the follicle. You can see the sebaceous gland there, and you can see these cells, these are the secretory cells. They're kind of just rupturing there and emptying in, as opposed to if we look here, this is our eccrine sweat gland, and you can't really see like anything about what's going on in the secretory cells. The secretory cells kind of look just like the duct cells. But here, I mean, they're kind of pretty obviously different. They're these full cells that are rupturing as they're emptying up there up into the duct. Okay. Questions on glands? All I want you to know about the nail is its function. So you don't have to worry about the structure of a nail. Sure, I've got the picture of it up there, but that's so we could look at it. And just be aware, all of the appendages of the skin are epithelial-derived structures that reside in the dermis. So here's dermis down here, and my nail pokes into it. So the functions of the nail are manipulation of small objects and defense. So for the functions of a nail, we could say they help with manipulation of small objects, they help with protection in two ways. They protect the distal ends of your digits. So for the distal surface of digits. But then they also offer protection and defense. So, you know, teenage cat fights. Girls might actually scratch each other, but if you're an actual cat, you're definitely scratching. So in other animals, nails are more important for protection than they are in us, but it's still a function of nails. So they can be used in defense against an aggressor. So that's what I want you to know about that. Hair can also be used in defense. By standing on end, it can make you look bigger. Again, not important for us, but for a cat, hugely important. So, and I've already told you the structure that stands hair on end. So think about that when we're thinking about the function served by the skin, like the hair is protecting in that way as well. So as far as hair goes, I'm not going to test you on the specific types of hair, but just be aware, vellus hair is the pale, fine hair that covers the bodies of children and adult females. Terminal hair is our coarse, long hair. We find it in our scalp and eyebrows. At puberty, we see it in the pubic and axillary regions. And I don't know what kind of vellus hairs all over males' legs because they say that for terminal hair, it's also on the face and neck of males. So you guys have the most dense vellus hair on your legs I've ever heard of then. I don't know. Nutrition and hormones affect hair growth. Yeah, so hair. I don't care that you know about the structure of a hair. So other than knowing that they're flexible strands of dead keratinized cells, the root is what's going to be in the follicle, the shaft is sticking up above it. But you don't have to worry about the medulla and all of that stuff, and all of like the nitty-gritty parts of the hair. You don't have to worry about that. I do want you to know all of the important parts of a hair follicle. So I'm going to give you
We get to do drawing today.
That's what you were supposed to be doing on your
No, I'm just
back.
kidding. Oh, but we're gonna go more in detail.
No, that's just the key.
Got it. I need to remember the revolution.
All right, well, it looks like we're all back, so let's just come together. This is like what I would consider the key. The whole thing is a hair follicle. We've got the root down here in the follicle, the shaft sticking up above the surface of your skin, an erector pili muscle that stands the hair on end, a hair root plexus that senses hair deflection, so that if something lands on the hair, then it will send a nerve signal so that you get whatever it is off your skin. This is a hair papilla. It's a dermal papilla that gets overtaken by a hair follicle. And that is going to have the blood vessels then that serve the hair follicle. So that's its function. Here's our sebaceous gland, which is secreting sebum onto the hair as it's growing past to make the hair soft and pliable. So hopefully you had something like that.